Alright, so in this video we go over section 5.2, multiplying polynomials. So in this section we are going to multiply any two polynomials, multiply binomials, square binomials, multiply the sum and difference up to terms, and multiply 3 or more polynomials. Alright, so to multiply any two polynomials we use the distributive property and multiply each term of one polynomial by each term of the other polynomial, and then we combine like terms. So this is pretty much the key here. And multiply each term and then combine like terms. And then so let's look at some examples. So when we have this example like 2x cubed times 5x to the 6th. The first thing we do is multiply the coefficients. Recall that the number that is written in front of the variable raised to a power, that's called coefficient. In this case, it's 2 and 5. Multiply those two. 2 times 5. 2 times 5. And then in this case, x cubed times x to the 6. X to the 6th power. Alright, so we're going to multiply 2 times 5, which equals 10. And then, before proceeding over here, you might want to recall that when we have x to some power m times x to some power n, that's x to the m plus n. In other words, when we multiply the same base, what we do here is add the exponents. Alright, so in this case, add 3 plus 6 to obtain 10x to the 9th power. Okay, so this is our final answer. Alright, let's do the same over here. And you might want to be very, very careful when dealing with a lot of variables at the same time. So in these cases, let's highlight the coefficient. Notice the coefficient here is -1. Okay, so we're going to have 7 times -1. So, and then let's go with the variables in alphabetic order. X, but notice that x, it's the only one we have, so that's just gonna be there. And then for the y's, that's gonna be y to the 4th and y to the 11th power. And for the z's, we're gonna have z to the 4th power times z to the 5th power. So if we multiply 7 times -1, we're gonna have -7. And for x, that's the only x. And then y to the 4 plus 11 and z raised to the 4 plus 9. So in this 4 plus 5 rather. So in this case, let's simply add the exponents using this low exponent that we just recalled. So that's equals to -7x, y to the 4 plus 11 equals 15, and silly mistake here, this was not supposed to be this x to the 15th power, so that's going to be simply x, and then y to the 4 plus 11, that's 15, and z to the 4 plus 5, which equals to 9. Okay, final answer. Let's look at the next example. Well, so in this case, we're going to use the property. Notice in this case, we're multiplying 2x times 5x minus 4. If you want to recall the vocabulary here, this one is a binomial because it has two terms, and this one is simply a monomial. because it has only one term. So we're multiplying a monomial by a binomial. And all we do is simply 2x times 5x and 2x times negative 4. So 2x, 5x, and then 2x minus 2x times 4. Okay, so in this case 2 times 5, that's a 10, and then x times x, that's going to be x squared. So I'm not going to write this 1 plus 1 anymore. I'm just going to go and add the exponents as I go. And then minus 2 times 4, which is 8, x. Final answer. For letter D, we're going to do the same, distribute. So in this case, we're going to have negative 3 times 4, that's a negative 12. And then when we multiply x squared times x squared, so we add the exponents, 2 plus 2, which is 4. And then negative times a negative is positive. 3 times 6, that's 18. Okay, that's 18. And x2 to the 2 plus invisible 1, that's a cubed. And then negative times a positive is negative, so 3x squared times 1 is simply itself 3x squared. Alright, final answer. Alright, this one might be a little bit tricky, letter E. So what about letter E? Well, in this case, we still distribute. But we are going to multiply power by power and coefficient by coefficient the same way we did it before. If it looks a little bit weird, it's because it has more than one variable at the same time. So in this case, we have negative times a positive 7, that's negative 7. And then I'm going to go variable by variable, x, y. So x times x squared, essentially this is x to the first and y to the first. All we do is add the powers. 1 plus 2, that's a 3, and 1 plus 1, that's a 2. And then negative times a positive is negative 3, and then x to the first times x to the first, that's x squared, and y to the first times y to the first, that's, we add the exponents just like we did here, y squared. And then negative times a negative is positive. 11 times simply xy, because in this case, notice the 11 is by itself. It doesn't have any other x and y's ready to actually to add, to combine those with. All right. Okay, for this one, multiply and simplify the product if possible. Well, first I'm going to explain the FOIL method in the next page, and then I'm going to go back to this example too. Okay, so multiplying binomials. So when we multiply by binomial by another binomial, we can use a special order of multiplying terms called the FOIL order. Okay. What does the FOIL stands for? The letters of FOIL stand for first, outer, inner, and last. To illustrate, well, let's multiply 2x minus 3 times 3x plus 1. So in this case, multiply the first terms of each binomial. In this case, the first terms of each binomial are so I'm going to write the whole product, so 2x minus 3x plus 1. So in this case, the first with the first. So 2x times 3x, that's going to give us 6x squared. Multiply the outer terms of each binomial. So if this is So you know we have two binomials. There's a middle place here. This is right the middle, if you will. So this is the outer of the first term. This is the outer of the second term. Outer with outer. That is 2x times 1. That is simply 2x. And then multiply the inner term. So now we do the same. So this is the middle, and this is the inner of the first term. This is the inner of the second term. The inner that are closer to the center, closer to the middle. The outer further to the middle. Okay, so all we do is negative 3 times 3x, that's negative 9x. And multiply the last terms of each binomial. So in this case, the first binomial, this is the first term, this is the last term. The second binomial, this is the first term, this is the last term. So we multiply the last with the last. So in this case, we are going to have negative 3 times 1, which equals negative 3. And at the end, all we do is combine like terms. So let me write this down. 6x squared plus 2x minus 9x minus 3. So in this case, the like terms are going to be the following: positive 2x rather, and minus 9x. The other two are not like terms. So we're going to have 6x squared 2 minus 9, that's a negative 7x minus 3. Alright. So let's do some examples here using the FOIL method to multiply this binomial. So multiply these two. So we're going to do the FOIL method. So we're going to do the first 2x times 3x, so that's going to be 2 times 3, which is 6. X times x, which is x squared. 2x times negative 4, that's the outer. That's 2 times negative 4, that's negative 8x. And then the inner, negative 7 times 3x. That's a negative 7 times 3, that's a negative 21x. And finally, the last of each. Negative 7 times negative 4, that's a positive 28. Which equals, well, combine these two. No, not minus 29. I was actually writing the same thing. And then plus 28. Okay. Let's do the same over here for letter B. Multiply 3x squared times 5x cubed. So that's 3 times 5, which is 15, and then x squared times x cubed. Remember, when we multiply the same variable, x times x, we add the exponents, 2 plus 3, which equals to 5. Multiply the following here. 3 times negative 2, that's negative 6. X squared times y squared. Well, in this case, we have x and we have y, nothing to combine exponents with. So we just write x squared, y squared. And then this is y times 5x cubed. So that's plus 5x cubed y. And finally, y times negative 2y squared, which equals, in this case, negative 2. And then y squared times y, that's y cubed. Okay. And now, if possible, we can combine like terms, but in this case, we don't have any like terms because, well, look at this. We have x to the 5th power, x squared, y squared, x cubed, y, and y cubed. So no like terms at all. Okay? So we're done with this example. Okay, so as I said before, let's go back to, well, in this case, multiplying a binomial times a trinomial. So let's do the following. So 2x times 5x squared. Alright, so that's 2 times 5, which equals 10. X times x squared, that's x cubed. 2x times negative 6. That's 2 times 6, negative 12. X times x, that's x squared. 2 times 7, that's 14, and simply x. Okay, and then we're going to do the same over here. Negative 3 times 5, that's negative 15 x squared. And then the next thing we do, negative times a negative, that's positive 3 times 6, that's 18 x. And finally, negative times a positive, that's a negative 3 times 7, that's 21. So now it's time to combine like terms. So in this case, if we have 10x cubed, but we don't have another cubed term, but we have a couple of square terms to the first power, and only one constant term. So in this case, 10x cubed, and then negative 12x squared minus 15x squared, that it's going to add up to negative 12 minus 15, that's negative 27 x squared. And then 14x plus 18x, that's going to be, so 32x, and minus 21. Alright, so now let's move back to, moving on. Go to page 3, squaring binomials. Alright, so very often times you're going to run into situations in which we're going to have a plus b, some quantity a plus b squared, or some quantity a minus b squared. So in this case, well, we have these formulas to expand those binomials. That's basically, if you want to label, this is the first term and this is the second term. So what we do is square of the first term plus twice the product of the first and the second plus the square of the first term. And in a very similar way, when we have the difference, all that changes is the sign of the middle term. A squared minus the square root of the first term minus twice the product of the first and the second, and then square root of the second, of the second term. And we have that in words over here. So let's see, where is this coming from? Well, so pretty much a plus b squared is that's the same as a plus b times itself, a plus b. So in this case, a times a, that's a squared. A times b, that's a b. B times a, that's ba or ab. It's the same. We write them in alphabetic order. And then b times b, that's b squared. Okay. If we combine these two together, well, this is a squared plus 2ab plus b squared. See how this matches this expression here? And of course, the same is for the negative version of it. Alright, so let's multiply this. Okay, let me do this one the old way. So pretty much something like the old way. I'm going to do that on this side of the page. So x plus 5 squared is the same as saying x plus 5 times itself. So in this case, x times x equals x squared. And then x times, well, actually, let's do the foiling. X times x, and then x times 5. X times 5 is 5x. 5 times x, which is 5x. And finally, 5 times 5, which equals 25. So combining like terms, x squared, 5x plus 5x, that's a 10x plus 25. Okay? So let's see if we get the same answer using the formula at the top of this page. So in this case, let me highlight this with orange and with green. And notice that we have a positive sign in between. So in this case, we're going to have the following. We're going to have, this is our A, this is our B. So we're going to have A squared plus 2 times A times B. And finally plus B quantity squared. So I'm going to plug in A, which is x, and B, which is 5. So this is going to be x squared plus 2 times 5, which is 10, and x and 5 squared, that's a 25. Final answer, same answer. So ultimately you can do it either way. You can use the expanding the binomial, the square binomial, or foiling. Either way should be fine. You can do it whatever the method you feel more comfortable with. So in this case, y minus 9, I'm going to highlight y with orange and 9 with green. Then I'm going to circle negative sign. So in this case, I'm going to have the following. I'm going to have quantity squared minus, in this case, 2 times quantity plus quantity squared. So y and 9. Okay, so all we do is square the y, that's y squared, minus 18 y and plus 81. Final answer. Of course, you can do the foil way, as we did it here. I'm not going to do it that way. I'm going to do the formula only. Let's do another one. Notice the positive sign here. We'll highlight orange and green. So in this case, I should use a lighter shade of green so it's easier to see. So I'm gonna have quantity squared plus, because of the positive sign, 2 times quantity plus quantity squared. So this is 3x. Over here we're gonna have the 2z and 2z. Alright, so in this case, let's square the 3x. Be careful when squaring the 3x. So over here, this powers affects both the 3 and the x. Okay, so we're gonna do that. 3 squared equals 9, and x squared is simply x squared. And over here we're going to multiply the constants, the coefficients. 2 times 3, which is 6, and then 6 times 2, which is 12, and then x times z, that's simply xz. Alright, and then over here, same story, square the 2, square the z. 2 squared, that's a 4. Z squared, c squared. Final answer. And one more, alright. One more to go. So in this case, that's going to be our a, and for m squared is going to be the role, it's going to play the role of a, and 3n will be the b. Notice the negative sign in between. This will be quantity squared minus, because of the negative sign, alright, so for m, actually for m squared, and then 3n. Now be very careful here. 4 squared, 4 and m squared. So 4 squared equals to 16, and then m squared here, you might want to recall another one. Let me do this one on the side. So m squared, quantity squared. Recall that when we have the power of another power, we multiply the powers. 2 times 2, that's m to the 4th. In other words, something like x to the m raised to the n equals x to the m times n. We multiply the powers. So what are we going to have here? Well, m to the 4th power. Then 2 times 4, which is 8. 8 times 3 equals 24. And then m squared times n. In this case, we don't add any powers because the letters are different. One is m, the other one is n. Again, don't forget about this. Don't forget about that. These two affects both the 3 and the n. So 3 squared equals 9, and n squared equals simply n squared. And we're done with this one. Alright. Now be careful. A very, very common mistake is to say the following. We have a plus b, quantity square. Very common mistake is to distribute the power to a sum or difference of terms, which is not correct. That's not the right way to do this. And in this case, let me give you an example. So you might want to suppose that a equals to 2 and b equals to 3. So I'm going to do the first example only. A plus b, which is 2 plus 3, quantity squared. In this case, this is not equal to 2 squared plus 3 squared. So 2 plus 3, which equals to 5, quantity squared. That's not the same as 2 squared, which is 4, plus 3 squared, which is 9. So the left-hand side is going to leave us with 5 squared, which is 25, which is not equal to 4 plus 9, which equals 13. So in this case, be careful here. Warning with this. Okay. Now let's see. Let's move on to the last page for this video, multiplying the sum and difference of two terms. So in this case, we have another very special product, which we call this product of conjugate binomials. Why do we call this product of conjugate binomials? Well, look at this. We have these two binomials AB, AB, but the fact that one of them is a sum, the other is its conjugate, that is the opposite in sign for the second term of each. And all we do is simply square the first term and then square the second, minus the square root of the second term. All right. So let's see where it is coming from. So let's do this the FOIL way. A plus B times A minus B. So I'm going to FOIL A times A, which is A squared. I'm going to multiply A times negative B minus AB. Then I'm going to multiply B times A, which is AB. And finally, B times negative B, that's negative B squared. Notice in this case how these terms AB and AB cancel each other. Okay, that leaves us with A squared minus B squared, right, which is the form that we have here. So let's apply this to these examples. Of course, if you want to do the FOIL way, that's up to you. But simply what I'm going to do here is squared minus another squared. So x will be in orange and 3 will be in green. This is going to be x squared minus 3 squared, which is 9. Final answer. Let's do the same over here. 4y will be orange, 1 will be green, and then we have the product of conjugate binomials, because notice we have the same quantities, but in this case different signs in between each of them. Quantity squared minus quantity squared. 4y and 1. Again, keep in mind that this squared affects both the 4 and the y. So that's going to give us 4 squared, which equals 16, y squared minus 1. Final answer. So it's same thing over here, quantity squared minus quantity squared. Alright, so quantity in orange, and this over here, alright, in green. So x squared and 2y. Alright, power of another power. We multiply the powers 2 times 2, that's x to the 4th. And then over here, same story as before. The 2 affects both. The 2 and the power 2 affects both the coefficient and the variable. So this is going to be 4y squared. Final answer. And one last one over here. Quantity squared minus quantity squared. So this will be 3m squared and 1/2. So again, keep in mind that the power affects both the coefficient and the variable term. So in this case, 3 squared equals to 9, and here we're going to have the power of another power, that's m to the 4th power, minus, in this case, 2 to the 1 squared, right, okay, 1 squared. In this case we have a fraction in which The power affects both the numerator and the denominator. So 1 squared, which is 1, and then 2 squared, which is 4. Final answer. All right. So in this case, let's apply what we have done in this section with multiplying 3 or more polynomials. So in this case, notice we have x minus 3 times x plus 3 times x squared minus 9. I'm going to focus first of all on the product of the first two. X minus 3 times x plus 3. Well, this, we already got the answer to that from the previous example. Alright, we did it over here. X minus 3 times x plus 3. That's going to give us x minus 9. X squared rather, x squared minus 9 times this x squared minus 9. Okay, and in this case, well, there's two ways we can go about this one. You want to do FOIL, or you want to square it and then square the binomial. Well, if you want to do the FOIL, that's enough, that's fine. X squared times x squared, and that's x to the 4th, and then x squared minus x squared times negative 9, that's negative 9x squared. Negative 9 times x squared, that's negative 9x squared. And finally, negative times a negative is positive. 9 times 9, that's 81. So in this case, x to the 4th, combined like terms, negative 18x squared plus 81. Final answer. And this is the end of this section. I'll see you on the next video.